Hi, welcome to solving quadratic and linear systems. This topic will be the last topic of chapter 3, and you're going to be looking at how to solve a system of quadratic and linears. You probably have seen this in grade 10, where we looked at two linear equations in a system, and we had to solve it, meaning finding the point of intersection. So right here we have two equations. We've got equation 1, which is y equals x squared minus 2x minus 3. So this is my equation 1. And equation 2 is a line, x minus x minus y minus 3 is equal to 0. This is a line because there is no, the exponent on the x is 1. Okay, it's represented in a standard form. Remember, line could be represented in this form, which is the standard, or the form of y equals mx plus b. So this is my second equation. So finding the solution. What does that mean? What does it mean to find the solution to this system? Meaning that I want the x and y value that will make this equation true and will also make this equation true. And the only point that will do that is the point of intersection. Okay, because as you'll see next when we look at the graph, that the point of intersection is a point on this graph, which is a quadratic, and is also a point on this graph. It's a point of intersection, so it actually lies on both graphs. Meaning that if it lies on this point, if it lies on this graph, it means it satisfies it, and if it lies on this graph, it also satisfies it. What does satisfy it mean? It just means that if you substitute the x coordinates of the points in here and in here, that will equal to the left side, which is the y coordinate of the point. And also if you substitute the x coordinates of the point here and the y coordinate of the point here, that will make that left side 0. So it makes this equation true and it makes this equation true. Okay, moving on. Let's see how we're going to actually solve this. So the first thing we want to do is we're going to solve using substitution, which means what we need to take is substitute the value of y into here, or even better yet, solve for y in the linear equation and substitute into the quadratic. I highly suggest that you would do that. Solve for the y in the second equation and then substitute it into this y right here. So let's do that. So from equation 2, what we're going to do is solve for y. If this was already in the form of y equals mx plus b, it would already be done because it's already solved. So what we do here is we're going to move the x to that side, the minus 3 to that side. So when I move the x over here and the minus 3 over there, I will get minus y is equal to minus x plus 3. But then I need to solve for y, so I need to get rid of that negative over here, which means I need to multiply both sides. Oops, what did I just do here? Multiply both sides by a negative 1, so I would have y is equal to x minus 3. Here's my rewritten second equation, which means what I'm going to do is I'm going to take this, which is y, x minus 3, and substitute it into here. So let's do that. Let's do x minus 3 is equal to x squared minus 2x minus 3. Then what we need to do is, this is an equation. We know how to solve this. We need to move everything to one side, making one side 0. So I need to move that and that. Collect like terms. So I will get minus 2x and then the minus x, which is minus 3x. and then the minus 3 will plus 3 will be 0. So I will end up with this. Now we can solve this using quadratic formula. The quadratic formula where x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a, where in this case a is equal to 1, b is equal to minus 3, and the c is 0. I know that you guys know how to do that, so what I'm going to do is actually use factoring. So instead of using a quadratic formula, which you'll end up getting the same answer, what I'm going to do is solve this by factoring, because it's nice and it's not a trinomial, right? It's only got two values, so I can actually do common factoring. And I can do x minus 3. So I know the two values are x is equal to 0 or x is equal to 3. So if you actually use the quadratic formula and sub these values into here and here and here, you'll end up with also x is equal to 0 and x is equal to 3. So what are the 2 points of intersection? Okay. So if x is equal to 0 or x is equal to 3, the 2 points of intersection will be coordinate 0, coordinate 3. Now I need to find the y coordinate. So how do I get that? All I need to do is use my original point, and I can actually use either the quadratic equation or the linear. I'm going to go ahead and use the linear because it's a lot easier to solve for. So the linear was x minus y minus 3 is equal to 0, or after we rearranged it, we said it was y is equal to x minus 3. So if I actually take these two values, 0, put it in here, I would get y is equal to 0 minus 3, which is negative 3. And if I take x is equal to 3 and put it in here, I would get y is equal to 3 minus 3, which is 0. So I know that that point will be 0. So the 2 points of intersection are 0, minus 3, and 3, 0. These are the 2 points of intersection. If I actually look at Desmos, and I graph the two, if I graph the two equations, x squared minus 2x minus 3 and x is minus 3, if I actually graph these two equations, I can see that I've got the quadratic equation, I've got the line, and then the two intersection points in this case are 0, minus 3, and 3, 0. In class, you actually looked through an example where the line touches the parabola at one point. It touches it barely at one point. And that happens when your discriminant, if you're using the quadratic formula, ends up being 0, which we call that line a tangent, meaning that it just touches the curve at one point. Another scenario where the line touches the curve at one point, if it actually touches it right at the vertex. So if the line was going straight that way and touching it right at the vertex, that's also a case where you would have one solution, one intersection point. If the line lied completely below the graph, it will not touch it. There are no points of intersection, which means that there is no solution for that system of quadratic or linear. There's no solution because the line completely lied underneath the parabola. So definitely feel free to use Desmos to kind of look at that, okay? Okay, another example of the solving quadratic system is looking at the cost and revenue functions. Now, the typical question would be find the break-even points. So that means we know that that's when the profit, the P of X, is equal to 0. Now, we knew that the profit is the revenue minus the cost. Another way of finding the break-even point is actually finding when the revenue is equal to the cost. So not that the profit is 0, but when this is equal to that, which is essentially what we do with solving linear system, because remember, this is like y, and that's like y. So if you actually take this y and substitute it into this y, you're essentially solving a linear system. So if we actually do that, we get negative 0.2x squared plus 1.8x plus 5 is equal to 3x minus 5. When you move everything to the left side, you would end up with minus 0.2x squared minus 1.2x plus 10. And that when you use the quadratic equation, you'll end up with two answers, which is you'll get two answers, okay? So when you solve for this, you'll get x is equal, so I'm not going to use a quadratic equation, the quadratic formula. You'll get two answers. You'll get a negative answer, which is negative 10.68, which is obviously inadmissible, because remember, x represents the number of items produced or sold, so we can't have negative values. And then the other value would be x is equal to 4.68. So break even happens when selling or producing 4,680 if the number of items are expressed in thousands. So looking at gizmos for the two graphs, we've got the revenue function, we've got the cost function, and we've got the point of intersection right here. Mind you, the point right next to it is actually the vertex. So this point in the black is not the vertex, it's the point of intersection. The vertex is very close next to it. The other point of intersection is down here, which we don't care about because x cannot be negative. So you can see that if we actually take a look back and see what's going on right here, this is the revenue, which keeps increasing until it falls down again after the value of something 4.5 or close to 4.68. But what you do notice here is that they're breaking even at this black point right here at 4.68. And what's happening here on this side, so beyond the black point, you can see that the cost, which is the purple line, is above the green, which is the revenue. So it's costing them more than the amount of money they're making. So they're actually not making any money if they produce more than 4,680. Whereas in this case, if they actually produce between 0 and 4,680, the green line, which is the revenue, is above the purple line, which is the cost. So at this point right here, if I actually just want to highlight that, this section of the graph right here, from here to here, they are making more money than it's costing them. So you see how, because the cost is below the green line, the value of the cost is below the revenue. So ideally, you want to say that the company should be producing somewhere between 0 and 4,680. Anywhere after that, it's actually costing them more than they're selling. And so, we can tell a lot from this graph. Not only where the break-even point is, but where ideally that company should be producing what values. What number of items that will increase their profits. So profit is increased definitely at this stage right here. Okay, so that's it for now. After you finish up, hopefully finish up answering the questions, and I'll see you later.